Okay, Mackenzie, you want me to start on 22?
Yes, please.
Okay, what did you use for your U substitution?
I didn't yet.
Oh, wow. What did somebody else use as their U
I have to
substitution?
figure out what the integration step was first.
Yeah, but I don't know the antiderivative of all that crazy stuff, so I'm going to rewrite it in a more simpler form. X squared plus 4x, okay? It's going to be okay. It's going to be fine. Everybody just relax. Okay, and then du is 2x plus 4. Right, so if I make that 1/2 du will equal x plus 2 dx. Okay, so now we're ready. So this becomes the square root of u on the bottom, and then du on the top, and a 1/2 in the front. And then we have to do the antiderivative first. So I'm going to rewrite this as 1/2 u to the negative 1/2 du. So what's the antiderivative of that?
U to the 1.
Right. Plus c. And then we have to substitute back in what our original u substitution was. That's it.
You already multiplied 2 by 1/2.
Say again?
You already did shouldn't it be 2 u to the 1/2 times 1/2?
2u to the 1/2 times 1/2.
The antiderivative and you did.
Right, so I did canceled the 1/2 and the 2, yeah. Sorry, a little slow today.
I can probably do the rest of these now because I
Okay.
have to.
Okay. Oh, nice. What problem did you want me to start on?
I need.
You can't do what?
I need some help. Well, I never know which one to make you.
For this one, it doesn't really matter because you can get the derivative of sine out of the cosine, or you can get the derivative of the cosine out of the sine just by switching the negative. I'm going to make u equal sine of pi t.
I thought you couldn't do that.
Why not?
I thought you could make you do the sign of the
Why not?
I don't know. I feel like you said that.
Oh, I did, but that was because there was only one cosine or sine in the problem. So since we have the other one in here, it's going to be okay. So, because that's just my personality, I don't know. So u is equal to the sine of pi t. So du equals what? Times pi, because you have to use the chain rule when you're taking the derivative of this. So du is actually pi cosine pi t dt. Yep.
Can we go over all the big ones?
Yeah, absolutely. Yeah, I know. Trig. Who made that up? Well, you shouldn't, because it makes our lives so much better. Yeah, pretty sure it does. No, I'm not. All of our music is based on trig functions. All of our navigation stuff is based off of trig functions. They're super, super important. No, I understand that, but you shouldn't hate trig, because without it, we would still not. We wouldn't have GPS. We wouldn't have iTunes. You know. Because that stuff, to translate music into digital, you have to use trig functions because they're sound waves basically. Okay, whatever. I did not. Okay, so now we're ready to substitute, right? So the sine of pi t is now u, right? And then the cosine of pi d dt is right here. So I'm going to make that a 1 over pi in front, and then a du on the end. So the antiderivative of u is 1/2 u squared. So I already had a 1 over pi in front, so that's going to be 1 over 2 pi u squared plus c. And then if I substitute back in what u equaled, my final answer is 1 over 2 pi times the sine squared of pi t plus c. Sounds like you're calling a dog or a cat or something. That's what we do when we're calling our cat. Come here.
Your cat comes as a man?
Uh-huh. Yeah. If you talk to it in a really excited voice, he like looks up and then comes and runs in there.
My dog doesn't even like something like that. No. No, and I know German. I know. You don't do the stairs thing for a while. Hurt a little bit. But he just keeps trotting.
If we call him and then like nothing happens, then he tries to play it off. They'll just like sit down in the kitchen like, yeah, it's coming in here anyway. You guys didn't. Totally. You know, because he's a cat. It's got to be cool. Okay, so for 24, what do you want u to equal? No, he just likes us. What? No, that's too complicated. Cosine of x. So then du is equal to negative sine of x dx, which means this seems a little unnecessary, but we'll just do it. That means negative du equals sine of x dx. So now we're ready to go. So u is cosine of x, so this part right here becomes u. So that's cosine of u. So we've done that. And then I have a sine of x dx left, but hey, what do you know? I've got a sine of x dx right there. Yeah, so that becomes negative du. So now we are poised to take the antiderivative. The antiderivative of cosine is sine. The derivative of cosine is negative sine. It turns into negative sine because of this negative in front. So that's negative sine of u plus c. And then again, we always have to resubstitute back in what we substituted for originally. So that's negative sine of cosine of x plus c.
Today, I was at Anthony down in the whole
Oh, nice. Sweet. College ruled. Nice.
How's
I
my
know.
assignments in 10
Oh, I never use pencils. Okay, we're still going. The scratchiness of the pencils makes me.
I need 25 to make the difference.
Yeah, a little bit. Okay. What do we got here? All right, so let's talk about the thought process we would use to figure this out, okay? You might say, I'm going to try and, yeah, so you might say I'm going to let u equal secant. But what's a derivative of secant? Okay, and if I use this as u, then I don't have a secant tangent, so I can't do that. How about if I let u equal tangent? What's the derivative of tangent? I don't have a secant squared, so the only option that's left is for u to equal to theta. Uh-huh. Which is 1/2 du equals d theta. Okay, so now when we rewrite this, we have lots of exciting things to do. We're going to replace this 2 theta with a u. We're also going to replace this 2 theta with a u. D theta becomes 1/2 du. Then, since this is a definite integral where they've given us numerical values, I'm going to replace these by substituting those into there. So if I substitute 0 in there for theta, I get 0. And if I substitute pi over 8 in there for theta, I get pi over 4. All right? So that was good. Okay, so what's the antiderivative of secant tangent? What trig function secant? Okay. So this is going to be 1/2 secant of u from 0 to pi over 4. Now it's Cameron time. You got this.
No, secant 1 over cosine.
Correct. Good. So I could rewrite this as 1 over 2 cosine u from pi over 4 to 0. Okay? Cosine of pi over 4. Cosine starts at 1. The graph is not going to be very helpful now because of the pi over 4 is not an easy answer. So you have to think triangles. Pi over 4 is how many degrees?
30.
Nope.
60.
Nope.
45.
Yes. So if you have a 45, 45, 90.
I remember pi over 3 is 30.
Yeah, well, I mean, pi over 3 is 60. The conversion factor is 180, so you just are always taking this number and dividing 180 by that. I know. So you have a 45, 45, 90, so that means that this is 1, 1, and the square root of 2. So that means the cosine is? Uh-huh. Minus. Now we can think about the graph to figure out what the cosine of 0 is. 1, and 1 times 2 is 2, and 1 over 2 is 1/2. Okay, this is 2 over root 2, right? But 1 over 2 over root 2, I flip it over, make it root 2 over 2. And then I'm just going to root 2 minus 1 over 2, if you want to make it as one fraction. What you got going there, Colby? All right, so that's a tricky one. It's a tricky one. A tricky one, that's what I said, yeah. Okay, 26. What's the variable? Okay. You got this. Oh yeah. Good. U is 1 plus tangent of t because the derivative of tangent is secant squared, which is in the problem. So that's, yeah, and that's a good clue, but you just have to make sure that the derivative is in the problem as well, and this time it most certainly is. Right. So this stuff becomes u cubed. And then conveniently the secant squared t dt is exactly what du equals, so no big deal there. And then I have to plug in those numbers. Tangent of 0 is what? Any idea?
1.
Nope.
0.
0. And then 1 plus 0 is 1. Tangent of pi over 4 should be fairly easy because we just figured out that pi over 4 was 45 degrees, which makes it a 45, 45, 90. And tangent is opposite over adjacent, so 1 over 1 is just 1. And then plus 1 is 2. So this disgustingly gross problem becomes this very simple one.
Are we going to be able to use our calculator to find tangent?
Sure. Only if you just want to be on the test.
How about they were taking to be on the test?
What's the antiderivative of u to the third? Good. 1/4 u to the 4th. And we're going from 2 to 1. So 2 to the 4th is 16. 16 divided by 4 is 4.
I'm trying to.
Give her a little ringer. And then if you plug in 1, you get 1/4. So again, I don't know. I just keep saying this. 1 plus tangent cubed secant squared, the area under that curve from 0 to pi over 4 is 3.75, that huge weird mess.
That's what I got.
So, how's golf going so far?
Good, except it's spring, so it's really cold and wet out there.
You guys
So
go outside yesterday?
yeah, we went out on the course yesterday. We stayed dry. It didn't rain in Elma.
Yeah. Well, okay. So
When I came home, it was raining.
when it was like maybe 5 minutes of rain.
Yeah, no, we were fine, but it's just cold, you know?
I
Yeah.
wear my
I don't think the girls get as cold as I do, because I'm not doing anything physical. I'm just walking around talking to kids, and at least they're swinging clubs and carrying.
I don't know.
I don't know.
We were taking Rogers yesterday.
Yes, they should feel bad for me.
No, we were taking Rogers yesterday. I think my pool was
Yeah, it's been cold. But the team is, to answer your question, Colby, we've got a really great number of kids. 12, which is perfect. Well, 15, but it's really kind of a core group of 12. Yeah. And there's some beginners, but most of them are returners, you know, and the returners are decent golfers.
So you're thinking it's
Uh,
like state champs again?
No. But hopefully,
Like new girls coming up, like freshmen that are actually good?
Maggie Harris is actually a pretty good. She's a freshman. She's got a real nice golf swing. So, you know.
Varsity or JV?
Well, she'll be JV because she's just a freshman. She's never played before, but she's got a lot of potential. Okay, woo, absolute value. Blah. I don't even know.
No.
Skip it. What you do is you go. No, I have no idea. You break this apart into where it's going to be positive and where it's going to be negative, okay? So if you plug in 2 here, 2 squared is 4, and so that's where it's going to equal 0. So you're going to break this into 2 integrals. One is from 0 to 2, and the other one is from 2 to 3, okay? Because it's only going to 3, yeah. So then the question you have to ask yourself is from 0 to 2, from 2 to 3, the absolute value does nothing, right? Because it comes out to be positive anyway. So we're still going to do the regular x squared minus 4 dx, okay? But from 0 to 2, what does it behave like? Yeah, we just switch everything around, so it's negative x squared plus 4. I'm not super confident in that. Let's check. So if I put 0 into here, I would get 0 minus 4 is negative 4, and the absolute value of that is 4. If I put 0 into here, I would get 4, so that matches. If I put in 1, that would give me negative 3, which is 3. If I put in 1, yeah, so you just switch around the things. So you just have to do those as 2 separate integrals and then add your results, okay? Is that what you did? Okay, good job. Is that something you guys can do on your own?
Can you do the first one and then I'll do 28 by myself?
Okay, so you just, that's true. Okay, you should be able, you just have to, Mackenzie, take the antiderivative and then plug in the thing. So just do that real quick.
That's the draw. Then, all right, I'll just do it for time.
Right? Okay, so if you put 2 in there, you get negative 8/3 for the first piece, plus 8 for the second piece, and then 0 just gives you 0. So 8 is 24/3 minus 8/3 is 16/3. So yeah, 5.3 repeating, or 5 1/3. Okay, then the antiderivative of this is 1/3 x cubed minus 4x, 2 to 3. So if you plug 3 into there, you get 9 minus 12. And then if you plug 2 into there, you get again 8/3, but this time it's positive, minus 8. So that's -3. That's going to be -16/3 again. I don't. And then negative minus is plus. So that's plus 16/3. So that's -9/3. So that's going to be 7/3, right? And then you add those together and you get 23/3, which is 7 2/3. Yeah, good, because if you plug in 1, then this equals 0. So from 0 to 1, it's going to be negative, and then the absolute value would cause it to switch. So let me, so we're starting with the integral from 0 to 4 of absolute value of square root of x minus 1 dx. So we're going to break that down into from 0 to 1 of 1 minus root x dx, and then we're also going to go from 1 to 4 of root x minus 1 dx. Try it again. Do some antiderivatives, plug in some numbers, see if you can get this one. Okay, so what was your antiderivative for the first one?
2/3 x is 3/2.
Ah, did you do,
Oh, you wrote it different.
okay, did you do negative root x plus 1?
4.
Oh, okay, that's fine, that's fine. So you did what now?
I got 2/3 x is 3/2.
Okay.
Minus x.
Okay. So if you plug 4 into there, square root of 4 is 2, 2 to the third is 8, 8 times 2 is 16, so that's going to be 16/3 minus 4. And if you plug 1 into there, you get 2/3 minus 1. So 16/3 minus 12/3 is 4/3. This is going to be negative 1/3, but then it becomes plus 1/3. So that one came out to be 5/3. Yeah?
Yeah.
For your whole answer before the one
Oh, I got that.
Okay. Do you see where you?
You probably
I don't know.
subtracted 1/3.
Can you look at my work and look at your work and see where the mistake happened?
I subtracted 1/3.
Oh, instead of adding?
Yeah, but,
Okay. Because it's minus and negative, so it should be plus.
Yeah.
Oh, no, I forgot my.
Oh, yeah, because I got negative 1/3 on here, so I just put that. You put the 4 in first.
Yep.
Then you take that and you subtract it from what you got in 21.
You plug the 4 in first, and then you go minus what you got when you plug in the 1. Okay.
That's what I meant to say.
Oh, okay. Okay. Just want to make sure. Just. So what'd you get when you plugged the 4 in, Colby?
I got, when I put the 4 in,
Uh-huh.
I got 0, 4 minus 4.
Okay, so we got an issue there.
Yeah.
If you plug 4 into here, the 2 means, since it's on the bottom, square root it. So the so square root of 4 is 2, and then the 3 means raise it to the third power, so 2 to the third power is 8.
Got me for that.
And then 8 times 2/3 is 16/3, which is not 4.
I don't know what happened. Oh, you know what?
Hmm.
I read it wrong.
Deuces.
Yeah, no, I read it wrong.
Okay, and did you figure out what you did wrong? Okay, so everybody's good? All right, so you want to turn those in?
Yeah.
You're a pretty needy guy, Cameron. That's okay. So 13, what'd you do?
Is it u equals square root of u minus 2u?
How about this? Ready for mind blown? No u substitution necessary. Because I can go the square root of u divided by u is going to be u to the negative 1/2.
So you just, oh, you're just
Uh-huh. And then if I go 2u squared divided by u, then that's minus 2u du. And I can figure out the antiderivatives of those without making any u substitution at all. Yes. 2u to the 1/2 minus, nope, because they gave us actual values, so we have to plug those in. I kind of like negative 76. Well, this is negative 75, right? But then you have to subtract another one from that. Yeah? Okay, then 14, same thing, no u substitution required. I'm just going to FOIL that out. So u to the 1/4 times u to the 1/4. When you multiply the bases, you add the exponents. So that's u to the 2/4, which is just going to be u to the 1/2. And then if I did outside together, that would be u to the 1/4. And then if I did inside together, that'd be another u to the 1/4. So that's plus 2u to the 1/4. And then last times last is 1. And then you just go through and do those term by term.
So there's 1 plus 1/4.
Huh?
1 to any power is still 1, even if it's to a fraction.
Yep.
So that's 1, 4.
Did you do the antiderivative yet?
Oh.
Ah, dang it. I was thinking, wow, you got those antiderivatives really fast.
2/3, 3/2.
So 5/4 is 4/5, which is 8/5.
You're about to say this, but I didn't tell them.
What? Jake says as he sprints from the room, headed towards Shelton.
They said she bought, she has a estate in New Harbor now. Yeah, I heard that.
34, 44.
I don't even wanna like have.
So I'm coming up with 49/15.
It's nice in the summer.
That's 3 and 4/15, about 3.3-ish.
Probably. But the Pacific Northwest is so big.
It is. But if it's on the on the water, yeah. Well, maybe you should text her and tell her, hey,
You are dumb.
you made a mistake. Let's get together and I'll show you.
Hey, I'll
I would not hang out with this stuff. That is not probably a good time.
So for 18, what's your really only choice for you?
I think that was,
3 pi. Or do you do
Yep, 3 pi t. So du is
What's the point of that?
3 pi over 2?
3 pi over 2.
Oh, yeah. You got to go for it? Yeah.
T squared. Divided by 2. 3 pi.
Oh, no, we're taking the derivative.
Oh.
Yeah. Come on, man.
There's just so many steps that you can make.
I know. Yeah, so 3 pi dt. So then if I just want the dt there, I go 1 over 3 pi du equals dt. So sine of 3 pi t becomes sine of u, right? And then dt becomes 1 over 3 pi du. And then 0 becomes, and 1 becomes, yep. Okay, antiderivative of sine is?
Negative cosine.
Awesome. So if you plug in 3 pi,
So wait, why did you get -1?
because you said the antiderivative of sine was negative cosine, so I just threw the negative in front. So if you do the cosine of 3 pi, then you have to do a complete cycle of the graph to get to 2 pi, and then go another pi from there. And so what's that? 3 pi is not going to be on there.
To go to pi.
Yeah, go another pi.
So you do that plus whatever you do.
No, so if you're, yeah, it's going to be the same, because here's the graph from 0 to 2 pi, and then it's just going to repeat itself. So -1, yeah. Minus, what do you get if you plug in 0 for cosine? So -2 times -1 over 3 pi is 2 over 3 pi. Phew. Who got you the horn?
Vicky, my boss.
Uh-huh, I know who Rachel is. Okay, and then 19, and then we're done? So U is,
So I'll do that times
U equals,
all times
I've never had as many
I've had really,
so DU is,
really?
She makes really good food. She makes really good food.
I wanted to have some
yeah, so 1/3 cosine U DU.
For us, when she made it for our party, it was like,
Let's do these first. So antiderivative of cosine is regular sine.
sorry, I was just checking.
Done.